Hello. Hello.
Hi, sir.
Have you started with anything?
Yeah, sir. Trigonometric functions. Same textbook. Link I had sent you a long time ago. It's the same one. Hello? Can you hear me?
Wait a minute. The same textbook. No? This is the textbook. No? Can you see my screen? Hello. Can you see my screen?
Yeah.
But it doesn't have any trigonometric functions or subtopic. Can you send me the link again?
What, sir?
Send me the link again. It doesn't have any trigonometric function का subtopic.
So you have to go to relationship mode.
Trigo function.
Yeah.
Amplitude. Okay. Okay, you have to graphically draw it. You know what is sine, cos, and tan, no? You might be aware, or you don't.
Yeah, sir, but not their functions.
What is sine function? How it is working? You know this? Whether this
Yeah,
is pi
words.
by 2, pi, pi by 2, 2 pi. You know what is pi, no? What is 2 pi? What is
Yeah.
pi by 2?
Pi by 2, it should be, uh, I'm not, I think it should be 30,
What is pi?
3.14. Oh, like you mean the value for pi by 2?
Angle.
I don't know, sir. What do you mean?
Pi angle is what? Degree. 180. No?
Okay.
And I say pi it is 180, no? Don't know this?
No.
Wait a minute. Okay. Pi is 180, 2 pi is 360. Okay. So
Okay.
for any so like one say any angle in terms of pi, I'll say pi is 180. Okay. Understood? And when it is circle like this, so the angle form is 360, that is 2 pi. Understood?
Yeah.
That's the basics of what is sine. Okay. So it is nothing but a representative of any system in a number line. The functions are nothing but a representative of any system on a number line. Let's say this is a number line. X, Y, yes, yeah, there is a circle. Let's say circle is
Yeah.
of radius unit 1. Okay,
Okay.
of radius unit 1. That means at this point, if I say what is at this point, what will be my x ka value and y ka value? What is my x ka value here? Perfect coordinate of this point. What will be the coordinate of this point?
The coordinate 0, 1.
1, comma 0.
Yeah, 1, comma 0.
What about this point? What's the coordinate?
That point 0, comma 1.
0, comma 1. What about this?
That will be minus
Minus
1,
1,
comma 0.
comma 1.
Yeah,
And this
and that will be minus 1, minus 1. Oh, minus 0, comma minus 1.
what about this? Okay.
What about
What about
what?
this? This one.
I'm not sure that.
If I'll draw a line like this, if I'll draw a line. So
Uh,
let's say this is
uh
x coordinate
yeah.
and this will be y coordinate, no?
Mm-hmm.
So this is same as this. Yeah.
Yeah, sure.
Yeah. I'll just erase this part and I'll write this is y coordinate. Okay. Okay.
Okay.
That means what if I use Pythagoras theorem, x square plus y square is 1, no?
Yeah.
Yeah. Yes. But
Yeah.
Pythagoras I can say because this is also radius 1 only. So this it is radius 1 only. Let's say this is an angle. It is an angle making angle theta with an axis. Yes or no? Yeah.
Yeah.
So if I'll say if only look at the what to say x coordinate, okay. So when I move the point from here to here to here, my x will become zero now. My x from 1 it is becoming 0. Yes. If I'll move a point from here to here. Yes or no?
Yeah.
Now y is becoming 1. Let's not consider y, let's consider x only. And from here again, if I'll move, it will become minus 1. And from here again, if I'll move, it will become 0. And then here again, it will become minus 1. So my x is moving like this. Okay. If I plot it on a graph now, so from 1, my x is moving just from 1, that is at 90 degree, that is pi by 2. Yes, this is 90 degree, no?
Yeah.
That is pi by 2. From 1, it is becoming 0. From 0 again, it is becoming minus 1. And from at angle pi, and then again, it is becoming 3 pi by 2, it is becoming 0 here. Then
Hmm.
again, it is becoming 1. Yes.
Hmm.
So it keeps on repeating like this. So, yeah, this is
Yeah.
my x. Similarly, if I plot for y also, y from 0 it is becoming 1, from 1 it is becoming 0, from 0 it is becoming minus 1, and then again 0. That
Yeah, like
means
this.
this is moving like this. That pi by 2 it is 90, it is becoming 1. At it is becoming pi, it is becoming 0. At 3 pi by 2, it is becoming minus 1. Then 2 pi by it is becoming 0. Understood? So, so for giving this convention, scientists decided to name this as a function. Okay, name this as a function. So what they decide, what they come after this, let's say there is a sine function. Okay, sine theta. Okay, what is sine theta? Opposite upon hypotenuse, that is y upon 1. No, if I say sine theta, that is opposite upon hypotenuse, y upon 1. That is y equals to sine theta.
Yeah.
Understood? Similarly, cos theta is adjacent upon hypotenuse, that is x upon 1. That means x equals to cos. So this point, coordinate of this point is cos theta into sine theta when radius is 1.
Okay.
When radius is 1. Understood?
Yeah.
Similarly,
Like, can you just explain that difference in the two waves? I didn't really understand fully.
I just see it is for see now. From 0 it is becoming 1, no? From 0 it is becoming 1 at
Yeah,
90
and
degree.
that is going from 1 to 0.
And
But
then from 1 it is also becoming 0. And then
yeah,
again, see at this point it is becoming 0.
because this is all the x coordinates and that is all the y coordinates.
Yeah, that's why I'm reading. No?
Okay, sure.
And that's how we generate this one. Scientists discovered this as a function and they gave the name as a sine function to this. Sorry, cos function to this because I told you this is x coordinate and this is y coordinate. So this is cos function and this is sine function. That's true.
Yeah.
Just and for any other function, like if I say radius is not 1, so it will be always like this. Radius is not 1, no, it will be r. So r cos theta and r sin theta. You can describe coordinate in terms of theta also. Understood? like
Yeah.
what I have described here. What you can do is you can copy this for your time being. They won't ask you, I know this, but this is something that you should know. How sine and cos should derive, like how it came to origin. They are nothing but the coordinate, okay, in terms of theta angle. You understood?
Yeah.
Copy this.
Well, so I understood the like that in this graph basically, uh, in that circle you made, if you want to find any point on that circle, you just make an angle from the origin, and that point will have the coordinates cos theta comma sine theta. Because of that, on those points 0, 1, 1, 0, 0, 1, minus 1, 0, you can plot it easily.
Have you done copying?
No, so on. So. Yeah, so.
Hmm. So see, sine function, whenever we talk about sine function, it always move like this. Yes? Yes or no? You know this?
Yeah.
It always move like this. So it completes its circle, completes its cycle in by period. Yes?
Okay.
Or 360 degree. You people prefer what angle or radian?
Angle, degrees.
Okay, degree. Sorry, my bad. Degrees. So 2 pi equals to 360. Okay. So at 90 degree it is positive 1. At 270 degree it is negative 1. It only goes max to max 1 or minimum to minimum minus 1. Okay. It only fluctuates between these two. If I multiply it with any, if you multiply sin theta with any number like 3, okay, so it will also amplify its value because I have already multiplied. No, so it will become 3 times of what it is. Understood? Like this.
Yeah.
But the period will remain same. Understood?
Okay.
Period will remain same, but it will amplify itself.
Yeah.
If I'll multiply inside, if I'll say cos theta,
So by pi, you just mean 180.
so if I'll say this is sin theta, so it will go maximum 1 and minimum 2. Yes, yeah, it will look like this. But when I say 3 sin theta, it will go plus 3, it will go minus 3. It will look like this. Period won't change, but it will amplify it. So amplitude will become increase. Amplitude will increase. Okay. But when I say sine 2 theta, okay, I am multiplying inside sine 2 theta. That means what? When I put pi by 2, when I put theta is 90 degree, when I put theta is what? 90 degree, it is becoming 180, no? The whole thing is becoming 180, sine 180.
Yeah.
Yes?
Yeah.
So it will shrink. It will shrink. It will go maximum plus 1 and minimum minus 1, but it will shrink. Cycle will decrease. Understood? See, for this, like period will shrink. If I multiply it with multiple, its period will shrink. If I do like this, sine theta upon 2, period will be like this. So you'll understand this in a coming exercise. Okay. So this is called amplitude. This is called period. Okay, any function which completes the cycle is called period, and from its mean position, from a mean, if I say my graph is like this. Okay, I'll say this is my mean position, not this axis. Mean position is always between the middle thing. Okay, if I'll say my graph is like this, so I know mean position is this. But if I'll say my graph is like this, okay, and maximum it is going, minimum it is going +4 and maximum it is going +8. So my mean position will be 8 plus 4 upon 2, that is 6. That means my mean position will be this. So I'll check amplitude from its mean position. Okay,
Yeah.
try doing the exploration first by yourself.
Yeah, so the exploration I've done.
Okay, you've done it already.
Yeah, yeah.
What about this one?
Oh, okay. Yeah, so this as well.
Okay, you might have drawn this also. So try to do this.
Yeah, so the range is it's between -1 and 1 for both.
What about the domain? Domain is given. So yeah, now I told you about the amplitude. Okay, so once you plot it on a GDC also, or if you don't able to plot it on a GDC also, you know what sign function is this? This sign function, yes. It goes from +1 to negative -1. Yes, -1. So if I multiply it by 2, the amplitude will increase to 2 now. Yes.
Yeah,
For this amplitude will be 2, for this amplitude will be half, and for this amplitude will be k. Okay, it is
yeah.
very predictable. Try this by yourself now. Graph the function with prediction. Don't use the PTC.
So y equals 2 cos x will just be like a form of vertical dilation on the graph. Half cos x will be again vertical dilation, but this time it will shrink. And a cos x will just the amplitude will multiply by a.
Which one you're talking? Fifth
Yeah,
one.
for 4 and 5.
Okay.
For 4, 5,
So,
and 6, because 6 is just so the parameter a will affect the amplitude.
so what this function represent? This function represent, because see, so maximum value is going to 3, no, from its mean position. So I'll say because I know this is a sine function, but maximum value is going to 3. So we'll say this is 3 sine theta or 3 sine x. Okay. Why x? Because my x axis represent degree. Okay.
Okay.
Try sketching the graph without in the graph paper without help of calc. You have the graph paper or you don't?
So the x-intercepts for 4 sine x are uh, they are 0 and pi, then 2 pi, 3 pi, 4 pi, so on and so forth.
180. Yeah, 180 to 60 like that, no?
Yeah, exactly. And for 2 cos x, the intercepts are pi by 2, and then 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2, and so on and so forth. 11 pi by 2, like
You're
that.
using calci, yeah.
Huh?
You're using calci.
Yeah, GDC.
Don't use calci.
So, but then
They are
how?
telling sketch the graph. They are telling you to sketch the graph. They're not using mentioning BTC, no? Use graph paper, no? Simple. 0, pi by 2, or I'll say how I got it 90, 180, 270, 360. That. Like that you have to draw. Okay.
Yeah.
You have to show the amplitude also. Because it is 4 sin x, not sin x.
Wait, so how do you do part B?
Which one? This is 2 cos x, no? So you know the cos function, how it is working. It start from -1. If it start from +1, so it will start from +2, na?
Can you repeat that? I didn't hear that. Yeah, it will start from plus 2, but that won't be the x-intercept. That'll be
That
the
won't
y.
be x-intercept. Label x-intercept graph. That will be, yeah, you start from +2. That means, but it will always gonna end, no? On 90. 90 degree it's gonna end. Then again at 180 it will be -2. Then again at 270 it's gonna end. Then again at 360 it's gonna +2 like that. So y intercept is 90 and 270.
So the x-intercepts won't change regardless of the a value, right?
No, no, it won't change. I told you, no, it won't change.
Okay. So
Unless
then,
and until we don't
so if
disturb
it's
x.
4 sin x or 40 sin x, the x-intercept will still be pi, 2 pi, 3 pi, 4 pi, so on and so forth. Basically, every multiple of 180.
Every multiple of
180.
for sin x talking
Yeah.
about. Yeah.
Whereas this will be like 90 to 70, then in those intervals and gaps. Yeah.
Multiple of what 90?
No, no, no. It'll be like step of 180 starting from 90. So 90, 270, 450, 630, what else? 810, like that way.
Okay. So this try figuring this out. This is easy, not that hard. Try figuring out the second one by one. Try if you're getting it all right, then nice. Otherwise, I'll do it.
Okay, so the first one will be 3 sin x.
Hmm.
Second one will be 5 cos x.
Yes.
Third one will be half, no, 1/4 cos x. Wait, negative half sin x.
1/4 cos x. What we're doing?
So, oh yeah, yeah, okay, I see, yeah. Uh, and then D will just be 1.5 sine x.
1.5 sin x or 3 by
Yeah.
2 sin x.
Yeah.
This is nice. When I put x का value, you have to get sin का value, y का value. See, what they are trying to say is here, if you put x का value, you will get this value. Okay, that means when I put x equals to 0, I'm getting y equals to 2. When I'm getting this, give me a second, I got a call. Okay, give me a second. Hello. Yeah.
Yes.
When I put x का value as 0, I'm getting y equals to 2. So on which function I'm getting y equals to 2? So let's say this function 2 into cos 0. So cos 0 का value is 1. Now we already discussed. Yes or no?
Yeah.
See cos 0 function is like this. At 0, it is giving me y equals to 1. So here it's 1, 2 into 1 will give me 2. So my answer for this is yes. Okay. Yeah.
Yeah.
Similarly, try for this 3.
So B should be, it will have to be how do you say it, a cos function, but it could be either of the two cos functions, 2 cos x or 4 cos x. Same, it'll apply to both. Same for third one, it'll apply to both half sin x and 2 sin x. As the smallest amplitude is half sin x.
Small amplitude is half, not half
Yeah.
sine. Okay. Do one thing. Draw a graph on a graph paper, not on a JDC. Okay.
Okay.
Draw a graph of sin x and draw a graph of sin 2x on a graph paper by yourself. Putting x, it's like putting x value equals to
How do you
0,
graph
putting x
2x?
value equals to 30, putting x value equals to 90, putting x value equals to 120. For calculating angles, you can, like if I'll say, use the graph paper like this. Okay. So when I put x value equals to 0, so put on GDC sin 0, you will get this point. When I put x value equals to 30, put on GDC sin 30, so you will get half. You will get this point at angle 30. You will get on this point. Okay. When I put sin equals to 60, you will get root 3 by 2, which is exactly 0.707. So at 60, you will get 0.707, and at sine 90 you will get 1. At 90 equals to 1. So like that you plotted for a complete cycle for both. Okay.
So I did the sine x. For sine 2x, what
Put
should I,
again. Yeah, put
like
again
when
extra. Yeah,
I would have put 30, I'll put sine 60, but put it on the actual for 30.
yeah. No, you put sine 2 into 30 like that.
Okay.
Don't put directly 30. Start with 15, and then 30, and then 45, and then 60, and then 90. Try like that. Okay, you'll get it. What I'm trying to
Okay.
make.
Okay, sure.
Once you graph it, just show me. Okay, whatever you graph.
Yeah, uh, so the sine 2x, like where sine x is 30, sine 2x is the same amplitude at 15. So it's like double the frequency.
Hmm. Now draw the full graph. No, it's not the frequency will reduce, I guess.
So frequency is double.
Frequency will reduce, no? What
No,
is
so
frequency?
like how
Given?
many of them are in one, like how many of the wave cycles are there?
In a particular time period. Like if I say
Yeah,
for this, if my frequency, if my wave is one, if you're taking it double, that means it will become like this. It will become like this. Yeah, it will look like this, huh? The second one, this one.
yeah,
Am I wrong or right? Yeah.
yes, sir. Like I
Yes or
could,
no? Hmm.
can I draw it? How do I draw
Yeah,
it?
you can like, draw the whole thing on a graph and then show me.
Hello, sir, can you hear me?
Yeah, yeah,
Hello?
Same.
Yeah, so can you give me screen approval so I can draw on this graph? Because you have the opposite of what you've said. Like you said, the frequency would decrease, but
No,
for
no.
me,
Frequency will increase. My bad.
oh,
I told you, no. Frequency will increase.
okay,
Yeah, I
okay.
have told you, no. All this
Yeah, no,
stuff.
amplitude is also the same. Like what I mean to say, sir, is where sine x is 60 for sine 2x, same value of y is coming at 30.
Hmm.
So
But
it's
because for this for sine 2x it will look like this, no? At 30 it is giving me this point. At 30, at 60 it is giving me this point. At 60, at 30 it is giving me this point like
yeah,
that.
at 45
It will
it's
look
giving
giving me
you
90 like that. Yes,
yeah, yeah,
like this.
exactly,
Okay.
yeah.
And similarly draw for sine x by 2.
For sine x, but I can already guess what it will be. Like it will be
It will be
half.
like this.
Yeah,
Yeah,
exactly. So I
it will
can
be like
use points zero. I can use the points. Which point? Zero.
you can
What?
use 0, you can use 90 also. Third
Zero
90,
and
45.
180. Right? Those points.
0, 90, 180, you can use 0, 90 and 180. And 90 will get this half or something like that. 45, 1 upon root 2. At 180 you will get 90, that means 1. Yeah, like this. Sorry, my bad. That means this point. So like this. Okay,
Yeah.
understood. And similarly for cos also it will react on the same manner. Okay.
Yeah.
So try completing the exploration 3 and tell me whether you're able to do it or not.
So when it's f of 2x, the frequency increases and the wavelength decreases.
Yeah, yeah, yes. Done.
Yeah, so the
The whole
period,
thing.
yeah, so the period for sin x is 180. Wait, no, sorry, one sec. Period for
Time 2x.
the period for sin x is 360. The period for sin 2x is 180, and the period for 2 sin 2x is also 180.
Yeah.
Yeah.
What about this fifth one? Do the fifth one.
So when you take it from sin x to sin half x, we already did that, where we would just the period would double. So if it's 360, it'll become 720.
Yeah. It's the same thing, okay? Until the this one. Now for the 3 sin x. That means what? For this, if my period is my frequency is 1, so for this it will be 3 times, no? 3 times the frequency. Yes or no? Pulse in my graph will look like this. So it will look like this, no?
Yeah.
Like this. Sorry. Because my amplitude won't change, so it will look like this. Yes?
Yeah.
Like check your graph and GDC and okay. So do for this and try for this also. By one. And check your this GDC on a GDC first. Sketch the graph of the domain. You have to sketch it first and then check it, okay?
Okay.
Sketch it by yourself and then check it. Don't just do it on a GDC and copy it. The whole purpose of doing it, see,
Oh,
everything in trigonometry can be solved using calculator. There is no need to learn anything. But the purpose of doing
sure.
this, all you have to know this. You should know this and then you should check it, okay?
Okay.
Done?
Yeah, sir. But sir, when they say frequency, like in what units? What's the
Frequency,
basis?
frequency is nothing. If I say frequency is it's in hertz mostly. Like when you go for the physics term, it is in hertz. It is per second. Okay, it depends. What is per second? Like kilometer per second, meter per second, like that. Like if I say the wavelength, okay. So
Yeah.
like it is moving like from if I say wavelength is moving from 0 to 360, okay, in 1 second. Okay. Now
Right.
my frequency has been increased. That means what? In 1 second it is moving 3 times, no? But actually
Okay.
what happened is that the whole wavelength has been shortened, yes or no? The wavelength has been
Yeah.
reduced. That means it's nothing but it's nothing has changed, just that the it has been shortened, and it has been that wavelength has been shortened. That's why the um, multiple folds has been increased. So you cannot justify that there is any unit for that. Just say the frequency itself. Okay,
Sure.
done with the second one.
Yeah.
What do you get for this sentence?
Oh, so I haven't done that. I've done what's it called?
This this one.
Yeah, 1B.
So it would be like this, no? 4 times, no? So for
Four
let's say
times
90,
instead of
180,
okay. But the amplitude is still one.
yeah, yeah, it will remain same as it is. So if my diagram is like this for cos x, so it has to be 4 times, no? That means it will be like this. My bad. I'm not seeing the wavelength like this. Yes, yeah.
Yeah.
So cos 4x, no? Yes or no?
Yes.
So try this too.
Try which one now?
Second one.
2B. So for 2B, it won't even happen one time in that domain, right?
Hmm?
Like 2A will at least happen one time. 2B will not complete its wave function even
0,
once.
0 to 720, no. Yeah, it won't. It won't. Because
It
till time,
won't. The frequency will be
yeah,
like it won't exist.
it
Zero.
won't. It will exist, but it will halfway, not halfway also. Like also this is one. This is two 360. Let me draw it here properly. This is 360. This is 720. So for this it will be like this. This will be like this. Yeah, for the
Yeah.
sine one. What about this? 360, 720. Cos is like this. Yeah, cos is like this.
Yeah.
Cos 1 upon 3 will be on a half. On this way it will be
So it won't.
like there. It will end here. It has to. If we want to finish it, that will be what 1080. I guess.
Okay.
Check it on GDC also.
What's up?
Check it on GDC.
Check it on GDC.
Yeah.
Okay. So the frequency will be one, and the period will be 720.
For this, no. What about this?
Yeah, and for that the frequency will be zero, and the period will be 1080.
Frequency will be one, no. Why
What's up?
frequency will be zero? Oh, sorry, sorry. Yeah.
Frequency is zero because the domain is up till only
Yeah.
720.
So what you can do is you can try some sums of the homework, okay?
Which ones?
Or this problem solving. So this one, okay, this
Okay.
one and this one. What do you say? I'll do some match the following is easy. Okay. Try this
Do
one to the homework. The third one. Okay. Let's do this.
So I can do the third one right now. Like it's mental math. It's not really.
Okay.
See, so the first one I think should be. Uh, sa- hmm, yeah, I think the first one will be sine. Uh, Sine what x? Sine 1.5x, right?
Why could be sine 1.5x?
Because shouldn't the peak be of a so the peak of a regular sine function over what corresponding x is that? Like a regular sine function, like just sine x.
That is 90.
It's 90, but here it's 270, so it will
So
be 1 by 3 sine 1 by 3x.
sine 1/3x.
Yeah,
What
and
about
then
this?
we it's a compressed cos function, so it'll be cos.
How many waves are there? See now. 1, 2, 3. So cos 3x.
Okay. Oh, okay, that makes sense. Yeah. Then we can do the same thing for d actually. D can be sine 4x.
1, 3, 4. Yeah. Sine 4x. What about this? Tell me.
This one is a cos. It's going to be cos 1 by 4. Wait, even more than that, right?
Cos 1, 4x. For C
Okay,
now. That is only for 1/4. For single wave, I'm getting 1/4 wave. That is 1/4 wave. 1/4 of.
okay, yeah,
Okay.
yeah,
So try this math problem.
sure.
Done? Hello?
Yeah, so for oh, like it's matching the equations. So I'm
See now.
okay. Wait, so for
We'll simple
number
them.
one, cos, so that will be b.
That will be this will be
Yeah,
this.
and
3, 3
3
times.
sine 2x will be
This will be this. This will be this. Yeah.
okay. Yeah,
3
yeah.
times. Times.
So it's, easy way is to just look at the 0 to 360 and see how
Uh,
many times it's there.
we'll see from the next time. We'll see from access practice session 3. Okay.
That 3, okay, sure. Okay, bye, sir. Thank you.